All right. Good afternoon. Welcome everyone to today's presentation. We are talking about architecting an agentic data pipeline. Thank you for being here today. So let's talk about what does that really mean, right? So with the impact that AI is making across all the different industries, the question is how we can leverage AI for data engineering activities, tasks, right? In a typical data engineer project, we go about to build out the data analysis, data pipelines, data warehouses, and data lakes, and so on, right? But then the question is, how can we leverage AI to help us do this? Okay, so we hear about all these agents, frameworks, and so on, but how does that apply for data engineering? And the short answer is that it applies a lot. There are a lot of use cases that we can leverage AI for. And in today's presentation, I'll just give you a bit of an overall introduction on how to go about and how to think about taking on projects like this and how to leverage AI to help you do your work. So, so good afternoon. With that being said, my name is Oscar Garcia. I'm a software engineer with cloud, web, and AI technologies experience. I'm also a author of the book Data Engineering Process Fundamentals. In today's presentation, actually uses some of that work to be able to now move it from a implementation work into AI-driven data analysis and data pipeline. So just follow that closely. I added the URL on the chat, so you can follow that. Please just join the repo for updates and keep following our work. All right. So the idea here is that we do build, when we start working on a data engineering project, we have to do all these activities, right? We have to do data analysis, study the data, be able to start thinking about the requirements, the technical specifications, design and architecture of a data engineering project. So here, what we want to be able to do is we want to pivot that concept and move it more into how can I leverage AI to help me do this. Okay, so when you get a chance and you go back to the GitHub repo, you can just look at the overview of the project, and you'll see what kind of process we follow to be able to do this project, right? So you can then just have some background on what is it that we're trying to achieve, and then you can actually go back and think about this material that we are talking about today, and kind of use those concepts and say, okay, I see how this fits in. Okay, so the goal here is to actually move from this manual scripting, coding, right, and actually interact with an agent, use AI to help us do this, right? So we become more of a we write specifications and governance requirements and design and so on, so the AI can help us, right? So, and the outcome of this is to actually have a system that can enable us to do data discovery and help us do data orchestration, data pipelines, right? From a data lake storage into a data warehouse. So we'll cover that step by step. Okay, so how do we leverage these tools, right? What is this whole magic behind this theory of using AI for doing data engineering? So you can think of it as in two areas, right? The brains in the hands of the process. So an AI agent, all it is a large language model that understands, right? Understands when we ask questions and we give instructions, it understands how to interpret that, right? It understands requirements, specifications. So that's how we can guide the agent to be able to do certain work. And with the ability of data being so driven by metadata, be able to be so descriptive about how it is that we need to do stuff, AI is great at doing that. So metadata basically is just describes everything we're trying to do. For example, the details of a table, a view, stored procedure, and so on, right? So AI is really good at understanding that and be able to understand the schema, for example, right? Definition of a table and so on. So because the large language models are so good at understanding requirements and details, like metadata from a database, then we can use the agent. But how does the agent connects into the database? How do we do that, right? Usually when we connect to a database, we use some data studio and we connect and we do our queries, or if we're doing APIs, we actually write an API that connects to that database, and we can run some SQL scripts and so on, right, through the API. So how does the agent do that? So when we realized that there was a need for the agents to be able to have access to systems, right? Then the industry created the concept of MCP tools, which is just a model context protocol to be able to discover tools for a particular system. So basically what that is that you can describe a tool. Think of it as an API, right? And that tool, that API, you can describe and say, I have the following API operations. And like, for example, select statements, or read the catalog of a database and so on. So those are the tools that then are exposed in the form of metadata to the agent. And the agent now, when he goes and he reads this metadata, is able to say, okay, so this tool enables me to connect to this database, or this storage, or this CRM, or whatever the infrastructure is. That tool just exposes the actions that are possible, right? And these are basically the hands of the agent. So the agent is able to use tools to be able to connect to different systems, and is able to execute an action, an operation. This is, for example, in the case of a storage, it can list the information that is in a bucket, right, on a data lake, the files that have been stored on that data lake. So that's really the magic behind the ability for an agent to connect. So think about MCP tools, which is important thing, right, to understand. But how does it work, right? So now we know that the agent, because understands text and has tools, which essentially are APIs, it can use this, right? But how does it really work? How do we engage this process, right? So basically the areas for us to be able to do what we call an execution loop is to first define a model, right? And the model is really this large language model. And it could be anything, right? It's not specific to one technology like Google, Microsoft, what have you. It could be any large language model, especially those that have been fine-tuned to be able to understand coding, right? That's the only thing to kind of know or notice and understand, right? Because if it is highly trained and fine-tuned for that, it'll be able to execute and be able to write better SQL statements, for example, or Python or C++, whatever it is that you're trying to achieve, right? So as part of that, there is the need for the discovery, right? And the discovery process really here is what the agent sees, right? The agent sees a bunch of tools, right? And automatically understand what those tools can expose and is able to use, right? So what does that mean, right? Expose and able to use. And how does this discovery work? So there's a whole orchestration, right, process here where we actually pair a model with discovery tools, right? And that basically is the essence of an agent, right? The essence of the agent is that now you have the brain, which is the model, and the tools, right, which enables the agent to be able to work. Okay, but now that you are equipped with brains and hands, what are the directions? How does this work, right? How do we tell it to do something? So this is where we actually generate governance, basically requirements in the form of system prompts that provide the guardrails and the core requirements for the agent to follow. So for example, when you are in a project, data engineering project, we often talk about naming conventions. What are the things we need to do? How do we build, for example, views and tables, and how do we index them? And there's a whole set of governance and requirements that we need to stipulate and define. So this becomes your system prompts, your governance. And this is very good for AI, right? AI is able to read all of this because this is all documentation. So it's really good at understanding this type of documentation. So what that does now is it enables us, it enables the agent to be able to understand the core requirements. And now we just need the user prompt. And the user prompt is really the execution that we need to do, right? So for example, it understands that an agent understands that it can connect to, for example, SQL server or a BigQuery database, and is able now to understand the requirements. And the user prompt, basically what it does is just ask the agent or tells the agent, create this view, analyze this table, the data in this table, right? It's that direct question, that direct action to be able to say, please, based on this table, give me the top 10 records for, right? And that is the action that it takes, right? And because databases are so good at exposing metadata, the agent is good at understanding what's in the table. So you add to the governance requirements, you can tell it, but look at the catalog of all the database and look at the description of every table and what they do, right? What fields do they have, and what kind of purpose the table is for. So we got to remember now, this is going a little bit about governance. So when we build databases, data warehouses, and so on, there's a little bit of documentation that we need to give, right, to the tables and to the fields. So usually this is called the metadata, right? It's the additional content that is provided to a system so you can, when you run your audits and your governance processes, you're able to know what table means, what each table means, and what each field within a table actually is for. And this is what the AI can leverage really good in understanding. And if you don't have this metadata, AI still can understand because there are patterns, right? There are patterns on the table that it knows, like name, descriptions, primary keys, and so on. So it knows basically, can understand basically some of the basic requirements for a particular table or view. But the more information you give in the form of metadata, the more accurate the agent is going to be. Okay. So how do we do the orchestration, right? So basically, to build an orchestration, just go back to our foundational concepts. And basically, we usually, when we start in a data engineering project, we need to get the data, right? And where is the data? How do you get the data? Usually the data is processed from an external system, and you usually bring that data over in the form of perhaps a data lake, right? In our case, we're staging the process from the point that the data is in a data lake, right? An external system has sent information to us, and it's a data lake, and we just need to go through the process of doing data discovery and analysis to be able to understand what it is that we are trying to build. So we also need to do the data warehouse orchestration. So once we know the data is in the data lake and is there, and we analyze it, and we sort of understand the data, the schema of that, then we need to kind of now move it into the data warehouse, right? And this is what we call orchestration, right? That's the data movement where we're mapping some of our discoveries into now logical and physical models, right? And logical models basically are just basically the structure that can enable us to understand what the data looks like with schema definitions in the sense of, or in the form of, for example, views, right? You can create views as a logical model, and that gives you the concept of what that data really looks like. And in the flow of a data warehouse, this is a very common pattern, what we call zero ingest process, which what that means is that there is no need to bring the data from a data lake into a physical table when we can build it by using logical models that are basically using data lakes as external tables and just basically modeling the data with some requirements, right? Requirements being the data type, casting, the naming conventions, right? Because the data could have all kinds of namings and formats, and you can just apply your naming conventions and so on. And this logical model then can be used to build the physical models, which are actually the tables, right? Depending on your requirements, because in some cases you may never need to do the physical model if your data is performing properly just with the logical models. All right. So our focus today is to cover that process, right? The process really is that we have some data that is on a data lake, right? It's in storage, is out there. And we want to go through the process of a typical data engineering project, which is, okay, so we're going to do data analysis, understand what the data looks like, to do some discovery, and stage the process so we can actually, from a data lake, we can actually create external tables on a data warehouse, so the data warehouse can actually do this zero ingest approach, which is just read the data from a data lake, don't import it into physical tables, because we need to do the analysis. We need to sort of understand what the data looks like. Enough of that analysis, then create our physical models, right? So create our logical models first, and then create our physical model. Just to refresh, right? Our logical models here are represented in the form of views. And the physical models are actually the tables that we're going to build, right? All right, so this diagram basically is saying that. It's saying, hey, we're going to have a data lake. We're going to use an agent model that's going to be able to read the discovery rules, right? Like the patterns and the naming conventions on the data lake. And we're going to be able to sort of analyze this and create some output to be able to tell our agent to how to build views and how to build tables and so on, right? And the table, and we're using, for this case, we're using BigQuery data warehouse. Okay, so let's take a look at how that's going to work. So the first thing is, when you get a chance, go into this repo, right? So this is the repo is basically giving us an overview of the process, right? You don't have to read all of this for now, but this just gives you background what we're trying to do here. Process some files, and it just gives you everything. It explains everything that we're trying to do, right? So you can take more time and look at this, right? And by the way, this is the repo that goes with this book as well. If you're interested, just read about it a little bit and get some information on the purpose. But here is, we're going to be looking at this folder, AI agents. And we can read the details of the README file as well. This gives you some background on what we're running and how to set it up, right? So if you're new to Python, for example, we're using Python for this. If you're new to Python, then basically just shows you a little bit of how to run this, how to install the dependencies, how to configure your cloud project, and so on, right? So some of the challenges that are about AI and things of that nature that we don't talk about often enough is that a lot of these things require infrastructure, right? Like cloud infrastructure and so on. And some of this can be a little bit complex because we need to provision the resources, we need to provision the service accounts, we need to provision the roles and services that are required to build this integration. So try to read this and understand that those dependencies exist. But the essence of today's presentation is to just kind of show you the concepts of how to go about this and how you can leverage AI, right? With the understanding that you're going to have some background knowledge is going to be required to understand a little bit cloud engineering to be able to set this up in a way that you can use it. All right, but you can read all of this here and it will just detail everything that we're trying to achieve, right? And what you want to do is use this agent pipeline. So let's jump into that now. All right. Let me increase this a little bit so you can see it. All right. So this is the GitHub repo that I was just showing you, right? Give me file for that. But we're going to take a look at, first of all, let's take a look at the main notebook. So this is Jupyter Notebook. And with this, we can actually run some Python code and be able to run our agent. So what we're doing here is the following. The first thing is going back to cloud engineering. I indicated that we need some dependencies, right? So for example, we definitely need a data set. And what is a data set? The data set is really a database in BigQuery data warehouse, right? So in the data set, it's required because that's how the agent will be able to go query the data set for the files that are there. We in the data warehouse, we need a bucket, right? We need a bucket, which is basically the data lake, and that's really where our raw core data is there, right? So the raw data that came from an external system is there. We need a project ID, and this is just the setup for this environment, right, with the region. So these are core requirements that are needed. But if you follow this set configuration file, right, I created a script that enables us to create some dependencies, right? We need to have a project ID. We need to create the services, enable the services for Vertex AI, BigQuery, and so on. And don't be overwhelmed by all of this. As I mentioned, this is just part of the cloud engineering requirements, but don't get too caught up on this. This is just for you to understand that's there, right? It's not magic that you just connect to one service and everything is set up. We have to do a little bit more work. All right, so let's go back to this. All right, so we get our keys. By the way, this is another area of confusion. A lot of people get confused. Do we need a Google API key or AI model key or not, right? So it really depends. So if you connect directly with a model, right? So some services will give you direct connection to the model. You need a key for that model. If you use a service like Vertex AI or any AI platform that services the models, all you need is the access to that service with the service account. And the service account basically, what it does, it connects to that service and you tell it what model to use, then that's it. That's what the connection is about. So just keep track of that, right? In this case, we're using Vertex AI and we're going to be using a service account for the connectivity. All right, so this is just saying that, right? This is just describing, hey, I got this. These are my keys, and this is what we can use. And I want to just to cover that you may need a key for your AI if you're connecting directly. All right, so here what we're doing here is we just have some scripts that are saying, we're going to use their service account and we're going to verify, first of all, verify the access, right? So the agent needs to connect to the to BigQuery, needs to connect to data lake. So we need to verify the access. So these functions basically, they are just giving us that ability to go and say, let me go ahead and connect with my service account and verify the access. So basically when you run this, it's going to just it's going to ping the data warehouse service, and it's going to list the databases the data sets that are available there. And if you remember, we actually selected MTI Dev as our staging environment for our agent, right? All right. So in addition to this, we query our data lake. And in our data lake, we can kind of see that we have a bunch of files there. These are GC compressed files. And we can note that we can notice that it's actually it has a date stamp for the file name. So those are patterns that we sort of start noticing, right? And the thing is that we can do that by looking at this, but this is the information that we want the agent to kind of discover for us. Or you can provide information and say, look for only files with this pattern, depending on what you're doing, right? So that's good. Okay, so now we're saying, okay, so how do we provide the governance, right? The how to the agent. And the idea of the system prompt basically is that you establish a set of governance and requirements for the entire process. And the agent is going to maintain memory and understand these governance rules and requirements. And every time you use a user prompt, it's going to be able to say, okay, he's asking me to build a stored procedure. I'm going to go take a look at my governance rules and see what the naming conventions are for my for writing stored procedures and so on. So this is important because what this does, it saves you also in the tokens exchange, right? You don't want to be sending this kind of prompts that are big every time you send a request, a user prompt. So the user prompts are supposed to be very small, and the system prompts are supposed to be larger, bigger, but you should only send it one time. So here's where we establish use this data set, right? For views, tables, and stored procedures. And that's part of our governance, right? We're kind of saying we want to follow this type of structure. And then when it comes to the requirements, we're saying, hey, we want you to analyze the data, identify the dimensions, identify the opportunity to improve the data performance by creating internal keys, surrogate keys, foreign keys, and so on, right? So here's where we actually do some project requirements. So things that we usually do, if you're doing SQL or you're doing Python, you usually do these transformations, right? This is where you actually start doing that level of transformation where you're saying, I want you to cast everything in datetime, do integers, and so on. So this is where you do the heavy work, right? Which is basically what we call discovery. That's part of the discovery process. All right, so now that we have that, now we start talking about, okay, let's build an agent. How do we do this, right? Okay, so here we're using the Google ADK SDK or library, but you can use any other ones, right? Of course, the code will change a little bit based on what you're using, but the approach is the same. So this we have here. This function is interesting, right? Because we're saying check manage server, right? A managed server, what that means really is if the tool is available on a hosted service, like for example on Google Cloud or Microsoft Cloud, then we want to be able to connect to that managed server, meaning they manage it, we don't, and be able to query what's available from that tool, right? And basically this just follows sort of a interface definition where all the tools basically are the same, and we're able to, they expose the same methods and properties. So we're able to say, for example, get the tools, right? And then basically that framework returns all the tools that are available from that service. Okay, so that is just to explore what the tool is, right? So basically what we do now is, how do we define the tool? Okay, so one of the things I came across here is that there isn't a real managed service, MCP service for Google storage, right? So what I did here is I built my own tool set. So if you want to learn about building tools for this type of integrations, then this is you can build an MCP tool set by following this file here, GCS toolset. And it just gives you a very simple Python module here with decorated functions, which are part of the framework to be able to say, this is a tool, right? So we describe the methods and say, this is a tool, or this is a resource. And resource, basically what the resource is metadata that gives the tool the capabilities to tell the agent what are the features available to it. So the resource basically is your metadata with specifications on what are the capabilities of that tool, right? And there are some basic prompts also that we can build out of the box if we need to build some customized tool that are specific to our use case. Okay, so this is very simple in a nutshell what the MCP service is built. Okay, so this is just a very simplistic approach, but it does what we need, which is we need something to to be able to connect to storage and be able to query our storage, basically. And that's what we're doing here. So we're passing service account key in the project, because we need to tell it where to connect, right? Where to connect, how to connect, and what project to use. So when we do this and we use our check manage server, basically what it's doing is saying, hey, I saw it, I'm able to connect, and I found these two tools: list MTA files, refile preview, right? And that is basically what we define when we decorated these functions with the NCP tool, right? Attribute. So that's how we discovered that. If it was a managed tool by Google, then we're going to be using a service that is on the cloud and be able to connect to it, and it will tell us what tools are available. And we're going to see that with the BigQuery tool that we are about to see. But let's connect to a more of a managed service now. So this is something now that's available, that it's already available by the framework, and we're just going to connect to it. So the requirements for that are that we need to provide some level of scopes and credit and credentials with scopes for that service. So that's basically here we're saying is we want the scope of all cloud platform, because we're going to use a lot of services like storage and BigQuery and so on, right? And don't get too hung up on all of this information. Just kind of understand the foundational knowledge here, which is your agent is not magically just going to connect, right? You need to give it some credentials and service scope so it's able to have access to it. So basically here we're saying is we're going to use this service account credential, and we're going to create a header token, and so we can generate a token, right? So basically here what we're doing is just generating a token that we can use to be able to connect to the services. And these are needed for managed services. So whenever you need to connect to anything that is hosted on the cloud, you're going to need to do that because you need to have the access to it, right? Who is the service account? What is the project? And how do they bill it, right? How do they bill that access and that usage? So that's basically what that's doing. So now this is closer to a little bit of a managed service, right? So we're using the BigQuery tool set. We're using those credentials to connect to it, and we're configuring the access, and we're saying, hey, we want to be able to use this credential or a BigQuery connection with this tool configuration, which is we want to be able to write, not just read, but write. Another thing that I noticed with some of the cloud services that enable you to do MCP connections is that they only allow you to do read only. You cannot write to the database. But in our case, we need to write. We need to create tables and views and so on. Right, so we can check and we can see that it found 11 tools like get dataset info, get table info, list database sets, and so on. Those are all the tools that are available for us to query the database. That's how the agent is able to say, you know, when I say to it, hey, read the catalog, it will use something like get dataset info to be able to understand what's available, right? So that's very important. Quickly here now, we pivot into the model, right? What model are we going to be using? So we're going to be connecting to Vertex AI, right? And that is really what's hosting all these different models. So we're not really just going to connect directly to Gemini. We're just going to connect to Vertex AI. It's going to host a model for us. So we select which model to use and to connect to it. So that's how we set up this configuration. Now, this is where the agent work comes in, right? So here now we're saying, okay, I want to build an agent, right? And I want that agent to use this model, right? Which is the Gemini Flash that we selected. And I'm going to give it an instruction, which is my user prompt, right? And I'm going to ask it to go ahead and connect to our data lake and find files with this pattern. And please give me an overall pattern to access those files, because I want to be able to create an external table, right? And the concept of an external table is that you can connect to a data lake with a particular file pattern to be able to load those files automatically, right? So basically, this agent goes and starts reading all of that, and it says, okay, this is what I discovered. I discovered that there's a bunch of gzip files, and this is the pattern that is more consistent with it, right? So it gives me the entire URL for the bucket with the file pattern for me to be able to read it. Right, so that now enables us to keep the pattern definition here and to feed that into our next agent. So now we're gonna work with the data warehouse agent. So now we created an agent for data lake, now an agent for a data warehouse. And we're gonna tell it to, hey, you are the architect, right? You're the data architect. Follow these governance rules, right? Follow this URL pattern. Go get some information about those files, right? And go ahead and confirm the schema. And we load up now the agent with the BigQuery toolset. So now the agent now knows that it's using a model and is using that tool with some system prompts, the governance, and a user prompt to be able to do basic role and understanding of what it needs to do, right? So now we told it we told the agent, you have a GCS pattern, create a external table. So that's basically what this user prompt is saying. Hey, create external table from this pattern. And what it basically will do is just go ahead and understand based on our governance and requirements what it needs to do. And it starts creating all of this information. Right, and it creates a schema and it's telling us what it's doing. So essentially what it did here, it went and it created a table on our data warehouse. Okay, so now that we have an external table, so the external table now enables us to query those files by using BigQuery. All right, so now we go in and ask the agent, okay, so now we have an external table. That's what we call staging. Now let's go ahead and create our logical models, right? Let's go ahead and start looking at that, look at the data, read the data, follow our governance and requirements, and start giving us a star schema concept, right? And basically what that is, the star schema concept is that the goal there is to identify the dimensions and the fact tables, right? And the dimensions and facts of that data source and be able to create this in a logical model. And basically starts defining dimensions for stations, for booth, for day, for entry types, right? In fact, tables for turnstile, which is really the core of the data that we need to report on. So it's really just building out this whole logical model for us. And of course, all of this, depending on how much information you provided to it, you need to review and make sure that it's actually following the things properly. Right, but it just builds all these views for us. Imagine all the work that just to basically get the core information broken down and documented basically is great. So now that we have these views, we can actually go and say, okay, now we got the views. Let's continue to do this work and let's go ahead and start building the physical model. Right, and the physical model now we're saying is, hey, we have a logical model. Let's use that logical model. Enough for that. Let's build our physical tables and use that, leverage that to be able to build that. So of course, AI for that is great. It follows those directions really good. So start saying, okay, I need to build this station table and start building the tables. Now, one thing to notice here is we got to be very, very detailed and granular because of the cost of tokens when using AI and the limits, right? But so for example, if I just go and say build entire tables, and if I give it too much work, it'll probably time out, it'll probably not do everything, it would probably make mistakes. So we got to be very detailed. So we have to start saying, okay, let's focus on let's focus on the station dimension. Let's just build that. Let's just do one step at a time, right? And it starts building out the station, right? Following our governance. And then we're saying, okay, what is the next step? Now that we have a table for station, we need to work out an incremental update strategy, right? An incremental update strategy really means is as we process new data in the data lake, we want to update that into our dimension table. And we use our logical model to be able to represent all the data sets, all the data that's available available, and we just do a merge update on the new records, basically. So we asked it, right? We asked, hey, do this, but we want to create a stored procedure for that, right? So starts working out the details. Hey, I'm going to work on a BigQuery stored procedure name, and starts telling me the name of it with the data set name. And it's just building all of this based on the information that it knows that exists for that dimension table and the logical view. So it just uses that information and it just builds this, right? And then we can go to the next step of creating the orchestration. And the orchestration is now is, hey, create a pipeline to do this. In BigQuery, there's a concept of pipeline, right? And pipeline really just means it's a task that you can build, and you can actually ask to create a call to store procedures or multiple store procedures, right? So, and then basically what it does is says, okay, usually this pipeline will just call this incremental update store procedure. That's essentially how it will do it. So, and here I say run, but it should be run the pipeline. So, and basically if we do that, and we ask the agent now, okay, now that you have it, run it for us. And then it will just go ahead and do select statements from that view for records that are not in the dimension tables. And basically what it did, it found 378 records, right? And then we can build things like testers to be able to, hey, give me the top 5 stations on that table and so on. And so basically what this is doing is just kind of going through, hey, what did we build, right? Give me the catalog now. We build a table, a view, and a bunch of views, external table and a dimension table and a bunch of views. And it's just built all of that for us, basically, right? So if you follow that project, basically, and actually adjust that to what you need to do, you can essentially understand basically how to leverage AI to do this kind of work. Of course, it's don't overwhelm the model by giving it too much information. Try to simplify the information that's available. Go one table at a time, one view at a time, so it does a good job. If you give it too much information, the AI, the agent, it'll probably start guessing. It'll probably make decisions, hallucinate, and give you something that you don't want. But at the end of the day, also remember that you need to review everything that's generated. But this takes us back from a long time ago. We tried to do code generation, and we tried to generate code, and that was just building templates that were hard coded. With AI, we can actually use actual requirements and let the AI use tools, MCP tools, to be able to query the systems and be able to understand what to do. With that, please take a look at the GitHub repo, start the project, send feedback if you can, follow the community as well, so you can join us for our next presentations. We're going to continue to work using AI to be able to do some of this data engineering work. And if you have any questions, I know we're running out of time, but I do appreciate everyone being here today. Okay, any questions? If not, don't worry. You got my contact information. Go ahead and send me a note or something, or you can go to the repo and add any comments on the repo as well. Okay, but I want to thank you for participating here with me today, for being here, and thank you for your time. Okay, you take care. Thanks, everyone.